Hello. We are live. Welcome on the learngrasshopper.com webinar series. Just let me know first if you can hear me as well. My today's guest is Sebastian again. Welcome again, Sebastian.
Thanks, Chris. Always a pleasure to be here.
So just let us know if you can hear me and Sebastian well. We already see that Asha Beam is already here. So good to have you here. We are going to talk about your project at the end. So that's really good that we are going to speak about people that are actually with us. Hammond is with us. I can hear you well and you can see me well. That's okay. We are starting in 3-4 minutes. So this is just a preparation. So we would like to check if everything is working correctly. There are some people already. Yeah. Hi, Hane. Hi, Rens. Yeah. The people can hear us, so we can see your comments because we can see your comments on LinkedIn, Facebook, and YouTube. So you can, if you have any question, so you can just post it. We have also Victor Streminski. Hi, Victor. Victor is one of my student, really active on Grasshopper and Tekla. So I hope you will going to enjoy this session. Okay, we have Hue, Tran, and so we'll start shortly. Just first thing, to get all the presentation and Grasshopper file that I have presented, and I'm going to present, you need to register. So there is still possibility to registration. I will show you where you can register if you haven't, if you watch it, for example, on LinkedIn Live. Actually, we met together with Sebastian live, finally, after Corona, 1 week ago, 2 weeks ago, actually. We've been together in the McNeil developer meeting. So it was a pleasure to meet you in person again, Sebastian.
Yeah, definitely. And now looking out here in Finland at the weather, we have rain and plus 10 degrees. The sun in Barcelona was pretty awesome, I have to say.
The same here in Oslo today. Today in Oslo we have the rain. So yeah, so we were planning that webinar, this masterclass in Barcelona on 26 degrees in the bar. So it was a better situation that that you doing that online. So, and I hope you enjoy, Sebastian, your weeks off in Barcelona afterwards.
Yeah, it's a nice place to have some holidays as well.
Yeah.
So
And
can
you
warmly
said that
recommend.
you've seen Sagrada Familia.
Yeah, I saw it for the second time now. It's always nice to see because they are still building it, as you might know. So there's always some new towers when you go there. And lately they are using all kinds of tools there, including Trimble tools and Grasshopper and Tekla. So that's really nice to see also how that helps to speed up that project.
Do you know for which part have they been using Grasshopper Tekla? For like some columns, foundations, or do you
I
have some
believe
data about
it's
it?
I believe it's for the towers, like this really intricate geometric shapes that they try to make production models for.
Yeah, interesting. One of the really famous use cases that you can use actually show how Gaudi use parametric type modeling, computational modeling. So now you can use it in Grasshopper. All
Yeah, I
right.
guess Gaudi was seeing this all along because he kind of his early drawings were not something that you could actually build at that time, but he was anticipating that in the future we might have better methods, and here we are with Grasshopper.
Yeah, and here we are with model-based project, right?
Hmm.
Okay, we have 2 p.m. Central European Summer Time, so we will start. As always, if you are watching that on Facebook, LinkedIn, or YouTube, so just give a like or share this event so we can reach even more people with this master class. Hi Pulari, hi Hoa, hi Jan. So I see that we have lots of familiar faces, so we are ready to go. So let's start it without further ado. So today's session will be about 1 hour. So everyone only registered will get the presentation and the Grasshopper file that I have prepared. So you can still register on learngrasshopper.com/masterclass/Tekla or scan this code. If you got already email from me before this session, so it means that you have registered already, and tomorrow morning you will get all the PDFs with the Grasshopper files. So for those who haven't registered, just go and check this website and register your email. For those who are seeing us for the first time, so this is our actually second webinar. So it's my pleasure to host Sebastian again. For the first session, actually, you can still find it on YouTube. This session was called "Take Your Tekla Design to the Next Level with Grasshopper Live Link," where Sebastian showed a little bit about basics, what is Grasshopper and how this connection can be obtained, where you can download and get the license and this kind of stuff, and how you can use it. So for those who are not familiar that much with Grasshopper Tekla Live Links, I really recommend to go there. I will just shortly send this link on the chat, so you can just save it and watch it later on. Okay, so on this session, this session will be more advanced than previous. We are not going to talk what is Grasshopper and just rotate some model to just show you how it's built. Here we are going to explore a little bit about hidden options that maybe you don't know. There is not that many, there's no hundred of components on the Tekla Live Link, but there are still some options that maybe you are not familiar. Maybe they can improve your productivity and make your script faster and make this workflow maybe optimized. So this is two things that for sure you will learn from this session. For those who don't know me, are seeing me for the first time, my name is Krzysztof Wojsław. I'm founder of learngrasshopper.com. It is a platform where I'm teaching engineers how to start with zero programming and enter the parametric world. I'm active on the YouTube, on the LinkedIn, so you can follow me. In addition to that, I'm also academic lecturer, where I'm having lectures about Grasshopper, about parametric design on the Norwegian University, and Ziggurat, academic lecturer in master program at Ziggurat, actually in Barcelona. So that was about me. I will give stage now to Sebastian. Maybe you can also introduce for people who don't know you, but I'm probably think like 95% of people that are actually here with us today are more advanced users and actually know who you are, but just to short introduce yourself.
Yeah, thanks, Chris. So Sebastian Lindholm, I've been with Trimble for a bit over 10 years. And predominantly, I'm occupied with complex geometries and parametric workflows, and in practice that has meant pretty much Grasshopper Tekla for the last couple of years. So I'm the author of that link and also support it and try to market it and position it and so on. So I'm always happy to hear your feedback about what works and what doesn't, because it's mainly developed based on user feedback. A bit similar to how McNeil develops Rhino and Grasshopper, as we found out in Barcelona. So they don't have a big roadmap either. They just interact with customers and users and base their development on that. So that's a really user-centered way of approaching things.
Yeah, for those who haven't been on the first part when we started, so we've been together with Sebastian on the McNeil Developer Days in Barcelona, 3 days. So actually, as Sebastian saying, so developers are just taking all the feedbacks from the users and actually building tools based on that. So you can also give a feedback even here in the comments. So please share your feedback if you like it, if the connection maybe something should be improved, maybe some functions they are missing. So this is the place for you today. So please feel free to comment. We're going to actually answer all the questions as it will be possible.
Yeah. So this webinar, like we said, it's about discovering maybe some hidden options and also about just learning how to use different components as efficiently as possible. And we're only going to be able to scratch the surface in 1 hour, I believe, but maybe there's material here for a couple of webinars if we want to. And I guess many of you are familiar with some of this already, and you have found your own very efficient ways to work. But this is just to give you some ideas about like what you might be able to do more efficiently and maybe in a different way. It's always good to see somebody else doing stuff with Grasshopper because you get used to certain patterns and certain components, and maybe this can give you some new ideas. We also have this frequently asked questions post on Tekla User Assistant, which some of you might be aware of. If you just Google Tekla Grasshopper and FAQ, you should be able to find it. And here we have a lot of questions that have come over the last couple of years, I guess, that you can go through and maybe find some answers for yourself. And part of this we will also cover today, and maybe some of the examples we're going to present I'll then add as questions onto this document as well.
This document is pretty awesome. I really found out lots of good stuff there. So I really recommend for all of you to check this out.
Yeah, it's like anything you do in general. If you have a problem, then somebody else probably has had the same problem before and written something about it. So this is a place where we try to collect like that kind of feedback and some workarounds and explanations. But with that being said, maybe we should just try immediately to discover some new stuff with the Grasshopper link. So the first thing I was planning to show was here about the beam rotation component. And that's a component that's used to solve situations like this when you have beams that are placed at an angle and they also need to be aligned with some kind of surface. So they can have a rotation which is not very easy to kind of calculate manually or even to calculate with Grasshopper itself. So how do you know that that's supposed to be 42 degrees or not something else? So to make this kind of calculation a bit easier, there's a component called beam rotation. So if I here generate first a circular beam, and then on top of that, I'm going to generate some columns. And here we are just dividing that bottom circle into points and then place some vertical lines and use those then as the basis of our columns. And what we want to do is to align all these beams now so that they line up after each other around the column. We can try to add some manual rotation here, but like you see, they all need a different rotation. We can't have the same one, so we need to calculate like what's the proper rotation to use.
But because now it's rotating by the word word plane, right?
Yeah, it is, but it gets even trickier. Like I said, when you then place them at an angle, here you could kind of figure out what the angles are by just measuring the angles. Mm-hmm. But you can have really tricky situations. But we're starting with this example. And if I then pick the beam rotation component, I will need first input the beam axis, which we had here. It's just these vertical lines. And then the desired up direction. And since these are vertical, the up direction will be in the XY plane, and it will start from the center of the circle and then go outwards. So I will fetch the center of this input circle and create a vector or a couple of vectors starting from the center and then going out just to the base point of each of the columns. And these will be our up directions. So I connect that to the rotation input. And because of how the profile has been defined. They are now perpendicular to the base. So we can add a 90-degree rotation to make them line up side to side instead. And let's make that exact. And that's the result we wanted. And let's then see what happens if we want to tilt this whole thing. Maybe it was somewhere else in the structure we were designing and at an angle to make it a bit more complicated. So first we see that the columns, they are still vertical, but we probably want them to be in the, like coming out of the plane of the circle. So we can get the plane from the input circle, the bottom circle, and from that we can get a vector, which will be the normal vector, that is the vector that goes straight out of the plane, and use that as the direction. And actually Grasshopper will do this automatically for us if we just use the circle directly as the direction. So it will know that we want the normal vector, the plane of that circle. And what we also notice here is that when we tilted this circular beam, it actually starts to warp because it also needs to be rotated. And we can use the beam rotation component for that as well. So here the up direction will be that same direction that we just talked about, straight out of the circle. But the next question is, what's the beam axis for a circular beam? And this is one thing that's perhaps not very intuitive, but this circular beam is defined using just 3 points, and they are then the chamfer type is arc, so it creates a circle. But in Tekla, for any beam or polybeam, the axis is actually from the first control point to the second one. So it would be from the start of the circle here to the first control point, and that's the axis we need to find. And because we can't get this beam back into Grasshopper, because that would be a circular reference, we need to instead work with this input circle and just divide it into using 3 points. And that way we can kind of recreate this output that we get in Tekla with 3 points. And then we create a vector here from the first point to the second point that you maybe can see here in Rhino. And that vector will be our axis. And now we plug this rotation to the circle, and it should line up with the rest, like we can see here.
Yeah, and just coming back to this divide curve. So when you are going to divide this curve by 3, like to the 3 elements, so actually it's Tekla is defining these 3 elements as well. So it's taking always the equal segments, like two equal segments, right?
Yeah, it's pretty much the same algorithm, because here it's still like a mathematical circle, but in Tekla everything needs to become like segmented. So internally, what the beam component does then is it recognizes that it's a circle as an input, and it creates these 3 points equally spaced and puts the arc chamfer type on them, and then you get this representation in Tekla.
Yeah, that's really interesting, and it's always from first to the second, like from the start to the middle.
Yeah, from the first to the second. So if you had a polyline with, 50 points,
Yeah.
the axis would be from the first to the second one.
Mm-hmm.
So that's something that's good to know, especially when using this rotation component.
Mm-hmm. So just to summary about the beam rotation. So you always need the one line, which is kind of perpendicular to the hole, and it will be our upline, right?
Yeah.
And the second is always axis.
Yeah, that's correct. So that can simplify. You can calculate the rotation angle. The output here is just an angle, a number. You can calculate it in Grasshopper if you know how Tekla works, but it's a lot of components, and I kept doing it over and over before just hard coding it into a component.
Yeah, so this component actually calculates the angles, right, between.
Yeah, it calculates like the angle that Tekla needs in order to rotate it correctly. So that angle then gets put here for the beams.
Mm-hmm.
All right. Next up, perhaps the only really hidden option. You probably know by now that for plates, let me just enable them. You can change the number of control points that you have. So if we look at the input here, we see that in Grasshopper, we have this jagged profile and then this more smooth one. But in Tekla, they look all warped and awful. And that's simply because when we transfer them to Tekla, we don't have enough control points to be able to represent them accurately. So the default number of control points that we have in Tekla is 100 maximum, or 99, I guess. And that's for historical reasons. Now in later Tekla versions, you can have up to 999 points. But that also means that the model can get a bit slower if you use a lot of profiles with a lot of control points. So the default is still 99, but if you right-click a plate component or a beam component, you can change the maximum number of control points that it's allowed to use. So here, if I increase it to 199, we can see that the plate in Tekla actually becomes accurate because now we have enough points to represent that shape. And for the second one,
yeah,
yep.
just one question. So if we'll change it for 199, and it seems that Tekla is not going to create this 199. It's going to find with the algorithm what is the like less than 199, but still more.
Yeah, so it tries to like minimize with tolerances how far we deviate from the true input. And if it finds something good enough with less control points, then it's happy with that. But it's allowed to use up to 199.
Mm-hmm. But what if we would like to specify some control points in our profile? Do we can do it, or do just Tekla, this component will always do component by itself?
Yeah, so in this case, since the first one is a polyline, so it has a set amount of vertices, which we can actually check. So 113. So since that's less than 199, then we will have the exact same here. For the second one, because this is now a smooth curve, that's a bit different. We can increase the number of control points, and let's add it, make it all the way to 999. But it is smooth, mathematically defined in Rhino, but in Tekla we will then get this massive amount of control points, which makes it appear smooth. But if you really zoom in, even though these are round, I think the type, but it will still be jagged, and that's just the way Tekla works. So for practical purposes, these are round, but in practice you have just hundreds and hundreds of control points. And it does keep these ones, that like the actual control points, the sharp corners, it keeps those in place. But for the curved parts, it just tries to estimate using then maximum now of 999 control points.
Yeah.
But at this point, it's maybe at some point I measured it, so it can be up to say 4 times slower if you have all your profiles and all your plates have this many control points. So if you're happy with like an approximation which maybe isn't as smooth, you can decrease this a bit, and you see how the control points start disappear. So that way you can kind of try to optimize.
Yeah, because it's the same with the reinforcement. Just a tip for everyone, you can also have this control of the number of points for the reinforcement. For example, if you have some reinforcement in the curve, so actually you can also play with that and actually can save a lot of memory, because usually there's thousands of reinforcement, and if you are going to use the same like let's say 100 points for every single reinforcement, so it can cause problems, but actually you can change it really quite quickly.
Yeah, that's a good tip actually. So you can also decrease it, of course, if you want a more crude approximation and are happy with that.
Yeah, especially with the reinforcement, when you, for example, would like to have, let's say, in arc, but actually you would like to have like a shape, like a straight shape, because the arc is just like a radius is really huge, and actually you don't like it that it will be in the curve. So you would like to, it will be at the rebar group at the list. It will be like a straight, so it's always increasing the number will help in this case, because Tekla will find the angle between each point.
Yeah. And also perhaps a newer option, which is only available in the last update, is that we can also change the number of control points when we create Tekla profiles. So using the Tekla profile component, I'm here using the same input to create some profiles. And based on those profiles, we then insert some beams. And you can see the same problem occurring here. But now if you have the latest version, you are also able to change that in the same way to get those profiles more accurately. And let's do it for the smooth one as well. The profile component is a bit slow because it relies on Tekla macros. But if we increase that second one to 999 as well, you can see that it becomes smooth for like all practical purposes.
Mm-hmm. And here we can also share a tip when you are creating your profile. It's really wise to disable these components while you're making some changes, because every time when you are going to make a change in the, let's say, profile definition, so this component will recalculate one more time, and you can see that it's 5 seconds for the first time and 4 seconds for the second one. So just to be aware that you can disable for that, and just when you finish with all your modification, then create new profile.
Yeah, that's a valuable tip as well. Right, let's take a couple more. And the next component I wanted to talk a bit about was the expand object component. So we have here in the extract group, we have all kinds of components for getting information from Tekla objects. You can, deconstruct your assemblies or components or beams, and you get curves, profiles, attributes, and so on. But that's not available for all object types. So for example, if I have this grid here and want to get that into Grasshopper, I can do that with the model object parameter. So that's not a problem. However, then if I want to get some information about that grid, there's no ready component for that. That's why we have this expand object component, and that will take any object as input and then display all the properties for that object here as outputs. So for this grid, we get colors, the coordinates, some options, and let's explore the origin, for example. So I can use that same component again on any of these outputs. And here I can see that the type is actually Tekla point, which is good because we have the Tekla point parameter, and that will be able to accept this as an input. And that way we can create a Rhino point based on this, this information. So now I have this point somewhere in Rhino. And then I'll also create a column in Tekla. And we can see that this is the origin of the grid. And then with the coordinates, we will get those grid lines. So if I go to the coordinate output, we see that we have a list of values, and that's actually one long text string, basically. So it will look like this, and that corresponds to, it's similar to what we have here in the fields in Tekla, where it's not just one number, it's just a string of numbers separated by spaces. So we can get that into Grasshopper and then start manipulating. So we're splitting that list to get numbers, and then we add them up like one by one to get incremental numbers to get the distance between each grid line and origin. And finally, we can create vectors from it, which we can use to move something around. So let's take that origin point or origin column and move that according to the vector information we have. And then we can use that to create more columns over here. And then we just need to do the same in the y direction. So I'm copying all of this, and we take the coordinates in the y direction. We change then just the direction from x to y. And we can move all the columns in the y direction as well. And to be able to get all the combinations, then we need to graft the input here. And it will create a column at each grid intersection for us.
So this workflow, you basically showed us like how to, without special components, you can actually get information, for example, like from the grid, because you don't have any option that actually can take information from this grid. So this expand components can be really useful.
Yeah, that's exactly true. And I'm also going to show for rebars the same thing because we don't have anything for rebars either. So if I pick a rebar group here, I get that into Rhino, but I can't get any properties without using this expand object. So if I want to get, say, the shapes of the bars into Grasshopper, I can try to get the polygons. And here we see points, and I'll use the expand object again. And here I see that's a Tekla point, so that's perfect, because as we saw previously, I can use those then to get Rhino points and create polylines in Rhino. So those should be now over here. The problem with this, like you see, is that the polygon output, it only contains the control points, so not the actual shapes of the rebars. So sometimes you might want the control points, but sometimes you want the actual shapes. And that's a limitation here because this expand object component is only able to show what's technically called properties, whereas to get the actual shapes of the rebars, we need to call a method, and those can't be like presented in the same way. So to get the actual shapes, we need to use a bit of C#, and I thought I will show that also as a tip, because even if you're not a programmer, sometimes you don't need to know much or do much in order to like access stuff that isn't available by using the Tekla API. So a quick C# component at this point. And the C# script component, I'll rename the input to rebar, and the output I want to get is the shape. And this output here can be used for sending messages and stuff like that, but we don't need that at this point. So I'm connecting my rebar here, and then I need to reference the Tekla API. So I do that by right-clicking, Manage Assemblies. And here there's a small button called Add. And then I need to navigate to my Tekla Structures installation. So Tekla Structures 2023 and the bin folder. And in here, I look for tekla.structures.dll and also tekla.structures.model.dll. So those are the two most important libraries. And they got added here.
I would just add that every time when you are working in the different Tekla version, let's say if you would like to use this C# script afterwards, so you need to have to update here with the same files, but from the previous version, right?
Yeah, that's the downside. So this will only work with 2423 because that's the reference that I added. But then once you have created your script, you can go back here if you work in another Tekla version and just replace this with some other version which you can browse or find here if you used it previously. So you can switch it, but that's the downside, like I said. So that's a good point. But for now, we're working in 2023, so now we're ready to put in some code, and it will be very minimal, I assure you. So I double-click the component, and first things we need to do is tell Grasshopper what kind of object we're dealing with, because it doesn't know.
Can you please just zoom it? Can you just please zoom it a little bit so we can? Yeah, great. Thanks.
Yes. So we're telling Grasshopper what kind of object we're dealing with. And because we added those Tekla libraries, we have this like IntelliSense, I think it's called, showing what options we have. And you will need to do some Googling if you're not a programmer to know exactly what you're looking for. But the API is well documented online. But I know that we want to have rebar groups. And then from those groups, we want to get the shapes. So here it suggests all kinds of attributes. Some of them are already available there in the expand object component. But then we have these get methods, which we don't get in the expand component. So I'm going to choose here get rebar geometries. And then there's an option if I want hooks or not. And I want them. And then I just assign this to the shapes output. And that's it. That's all the coding you need for this particular use case.
That was really quick.
Yeah, yeah. I'm trying to show that it doesn't always need to be scary.
Yeah, just a thing to find out in the documentation, right? But if you know what you are looking for, it's easier, right?
Yeah, definitely. And you can always ask somebody else to write that code in Tekla forums or something, as long as you know how to then use it in Grasshopper. But now we're ready. We get some kind of output here. It says Tekla rebar geometry. We can use the expand object on that to see. We get bending radius diameter. So the shape is here. And let's continue with the expand Tekla polyline. And finally some points. And that's when we are happy, because as previously, we can get those points. And then we can just create a polyline using those points. So now we get the actual shapes of the rebar with offsets and everything into Grasshopper.
Yeah, just to briefly just show maybe some not all of people just grab that the difference. So first methodology was to grab the just control points, and that it will also can give you a kind of shape that actually is like in this case U shape, but actually as you can see this green, so it will be in the just maybe I don't know 2 meters interval, or let's say 1 meters interval. But when you would like to get actual position of the all rebars, so this is the method. And of course you can maybe also connect this polyline to, let's say, pipe component, so you can also get the radius like a 3D shape for those who are interested a little bit more. So maybe if you can also get the actual size in Rhino. But
yeah, that's a fair point, because we do have radius values. So yeah, that's just a number. So I can use that directly
just be
here.
sure if you do not have meters, so it will not.
It should be, yeah, that's a good point. It should be millimeter in this case. So there you have some thickness on them as well.
Yeah. So this is also a good way to just visualize how reinforcement will look like in Rhino.
Yep. So do we have time for one more, or do you want to?
Yeah, no problem. It's 2:30, so yeah, still go ahead.
I had one more topic I want to talk a bit about, and that's about finding like faces and edges of geometry, because there are some gotchas here that are good to be aware about. So regardless now if your geometry has been generated in Rhino, or if you have placed something in Tekla, if you want to go and find like let's say the top surface of the geometry, there are different ways you can do it, but probably one of the first step if you're dealing with a B-rep, which we will be here. So let's just back up a bit. So what I'm doing is that I'm referencing in a slab here from Tekla structures, and then I'm converting that to a B-rep in Rhino using the convert to B-rep. And here I might also mention the solid type input, which is fairly new. Here actually you have options if you want to make the conversion a bit more efficient. You can use raw, which will disregard all the fillets and all the cuts and things like that on your input geometry. Or then if you actually want all the fillets for the profiles and everything, you can choose high accuracy. So this is something you can sometimes need to change. But anyway, we do get the B-rep here. And then we want to find the top face. So we are going to deconstruct the B-rep. And that means we get all the faces. Here we see we have 6 faces because it's a block basically. But we don't know which one is at the top. So what we first can try to do is just use the list item component and go through them one by one. Index 1, 2, 3, 4, and at 5 we can see that we find that top surface where we generate a surface treatment, and it's also visible here in Grasshopper. But the problem is then that we use the index number. So what happens if we instead reference another contour plate or slab? So if I pick this one, you can see that index number 5 actually is something else. It's the side. So it's not deterministic. That would be index 2, which means that I can't use the same kind of algorithm to find the top surface of both these objects. And also this might change between different Tekla versions, between different Rhino Grasshopper versions or different Link versions. So the number of the top face will be different. So you can't really rely on it. So we need to find a more clever way to determine which face is at the top. And the first thing you might want to try is just to get the center point of all the faces using the area component. And then maybe find the point or the surface which is at the top. So by deconstructing the center point, we get the Z component. And let's see if you can show it. And you can see here that one is at 1,000 millimeters, one is at 0, that's the top and bottom, and then there we have the sides. So then we just need to sort the input faces according to these values that we found. And now we have a list of components, a list of faces, which are ordered now from top to bottom. Or actually they are from bottom to top, now come to think about it, so we need to reverse that list. And now they are top to bottom. And that works for both of these. But I want to make it a bit more complicated, so let's try also with this tilted slab. And as you might guess, that will fail.
Because it's not the highest, it's not on the top of the block.
Yeah. And here you, of course, I mean, Grasshopper doesn't know what you actually want to do, and you have to somehow formalize, like, what am I actually seeking? Is it the biggest surface that points slightly upwards, maybe something like that?
Mm-hmm.
But there are like, depending on what you actually need, you can then try to define rules for getting that surface. So here, for example, maybe I want the surface that's farthest away, like in the Z direction from the outline of the slab. So that would also give me this, because the outline is here at the bottom, so the farthest away surface would be here at the top. So let's try that. And I can deconstruct the slab with the deconstruct plate component to get the boundary. You can see it in green here in Grasshopper maybe. And then I get a plane from that boundary and a vector in the normal direction, like we did with the circle in the previous example. So that's the direction. And then I want to see what surface is lying in that direction. So I can get here the face normals for each of the faces. And I'm not visualizing this in Rhino now, so it might be slightly confusing. But basically I have all the normals, all the vectors out of each of the face down below, and at the top I have then the direction from the outline of the slab upwards. So I can measure the angle between these two components. And if we take a look at the values, you can see these are in radians, but we have some values which are 0, which means they point in the same direction. Some values which are pi, that's 180 degrees in the opposite direction, and the rest are the sides. So I can sort according to these angles instead. And then I remove the reversing again. And now I do get the top for this and this. But there's one more trick here, because this last slab was actually not defined in the XY plane. it has been defined here in the XZ plane, like you can see, and then just extended really thickly. So that means that the surface farthest away from these points is on this side. So again, Grasshopper doesn't know what we actually want. We need to somehow try to formalize it here. So let's try one more time. And this time we want to get, let's see, what's the best way? I almost need to look at what I did last.
Yeah, maybe finding perpendicular lines to the middle.
That could be one. Yeah, there will be like many different ways you can do it. But I think the one I arrived at is that what if we take all the surfaces that point roughly upwards, like their direction is anywhere above the XY plane. So we can do that by just getting these face normals and compare them against the Z direction. So we see we have some angles which are, again, 0 will be straight up, 3.14 will be straight down, and 1.57 is like in the middle. So everything between 0 and 1.57 or half a pi will be pointing somewhere upwards. So we can see if it's smaller than, let's say, pi divided by 2. And then we can use the cull pattern component to get all those faces and filter out just the ones that are pointing roughly upwards. So I'm going to decrease the tolerance here a bit. And now we find that we have one face here, and then these two faces here that are pointing roughly upwards. Sorry. So then the final thing is just to decide like which of these two faces do we want, and we want the bigger one. So we can get back here reusing this area component to measure the area, and then we sort the list, sort the faces according to the area, and then we get back down here to pick the first one, and we need to again reverse the list because it goes from smallest to biggest. And finally, we have an algorithm which accepts all these three and finds the top surface. And for good measure, we can also add in those two over here and see that it actually works.
And this is how you create algorithm, right? You need to check out and check every single case if it's working. So it's great that it will work with index for one, but afterwards we have many situations, and it showed you a lot of good implication. There's some comment that someone is using Wombat plugin, but you can sort your BRAP faces by direction. And I think there's some, yeah. But still, you will not sort it everything and every single situation.
Yeah, but that's a good tip. I mean, there are plugins and third-party solutions for pretty much anything in Grasshopper. Personally, I try to keep it as vanilla as possible when I share scripts and so on, yeah, and try to learn, teach people. But if you find a plugin that helps your use case, then definitely you should use it.
Yeah, that was good one. Okay, do you have something more?
I think this is good for this round. So
yes, yeah. Let me see. Now I can. There is some questions. Let me see. Maybe we can answer that. Thomas, the control point option could have an option for automatic control point count. It would calculate the required amount automatically. So an optional override for the current approach. So automatic option when you contact it, when maybe is seeing maybe profile or that needs more control points that, for example, should. So it's maybe calculating the amount that actually is taking from the curve in Rhino, right?
That's such a good solution or suggestion that I wonder why I haven't been thinking about it. Yeah, for Polyline that makes perfect sense. We'll take that on board. Thanks.
Yeah, And this is how we developed together all the Tekla Live Link. Okay, there is Richard. Hi, Chris and Sebastian. My question is, can you create a concrete beam where the profile is not perpendicular to the lead curve, creating a parallelogram like solid without cutting edges? Profile is not perpendicular to the lead curve. Okay.
Yeah. I mean, you could use a polybeam, I guess, in some cases, but generally, like the start and end of any beam will always be perpendicular, and then you need to use a fitting or a cut to make it at an angle.
Yeah. And there was more question. Can we export this Grasshopper model to C# code?
Not in any easy way. I'm not exactly sure how that would be done.
Yeah. No, there is no automatic way to just export that to the C#. If you will, you can actually write everything in C#. So what you are having in Grasshopper, what Sebastian have shown. So actually you can create with C# code and actually send it everything with the Tekla Open API, but you cannot just export it just easy.
Yeah, and a comment to that also is that with this scripting components, you have automatically available the Rhino and Grasshopper APIs. And I know some people like to use it that way. So rather than using 100 components to make something tricky, they might just find it easier to use the Rhino API and just code it for themselves here. So you have options to use code for different purposes if that's something you're more comfortable with.
Okay, there is more questions to your presentation. So yeah, we'll see if I'm going to present my topic, but maybe it's a good topic to just make it another presentation. Pulari, can we get the bold center line from expand object option?
I haven't checked actually if that's a property or something else. Do I have any bolts here somewhere?
It looks like your Tekla master model where you have every single object.
Yeah, it becomes a 2 at some point. Let's try to reference in that. I get the bolt array. Yeah.
I also really curious what results you will get. Okay, that's a lot of info about that.
Yeah, positions. I guess from the positions you could infer the center line. If you have the position and then the direction somewhere.
But maybe it will be the same as with the rebars that actually need to. That is again.
Yeah, that might be. I can't now straight away tell if it's possible or not. But you could perhaps experiment yourself as well.
Okay. Let me see. There's lots of questions. So yeah, questions are most important to answer. That's why we are here. Steven, what can we do when a Rhino input curve results in the transparent polybeam in Tekla?
Transparent generally indicates that it's invalid in some way. Could be because I don't know, maybe you, Chris, know better, but sometimes when the control points are on top of each other or something like that.
Yeah, I think the best way when you go to this one is to simplify curve just to see and use the compound and simplify first. Because most of the time when I see this problem is coming, it's just the two control points are really short distance atop to each other. And if we have a huge profile, so they are going into each other, so that's why we crush. So I will always try to first end this polybeam into really small one just to see if there's a profile, just to see it. Afterwards, simplify. If not simplifying, so maybe rebuild. It's always want to help. Like you can also use the rebuild component. And actually, you can change the count of the numbers of the curve, so you can change it how many points it will be, and you can actually easily define that. Sometimes it's because there are some corners are too sharp, or some radius are going into each other. So maybe it can. I've been with this problem with pre-stress reinforcement, where you have lots of curves, double curve. So actually you have to create item. So that was solution in some of the really extreme examples. So actually you have to create an item, not a beam. All right, let me see. Asha Beam. Hi Asha, can we create variable cross-section from Grasshopper to Tekla?
And not at this point, it's only the fixed profiles, I'm afraid.
Yeah. Can I use Grasshopper and Tekla structure without Rhino? This is from Mateusz's question, and actually you have answer for that.
Well, you will need Rhino installed, but if you want to hide away the Grasshopper or the Rhino Grasshopper interface, you can install the Grasshopper component into Tekla structures. And actually, just for fun, I can show how it would work with the last example we did. So let me save that fine top surface component, remove some of those. And let's see what happens if we load it into the Grasshopper component. It was that one. So here, because I didn't filter the attributes, we got all kinds of stuff here, but regardless if I now insert it, it does run that Grasshopper script in the background without anybody needing to see Grasshopper or Rhino. And it will start Rhino automatically if it's needed. So that's one way to use Grasshopper without seeing Grasshopper or Rhino.
Yeah. Actually, good option. So someone else can create a script, Grasshopper script, and you can just use it by this dialog box. Okay, let me see. There's some more question, but we have the actually guest here. So maybe we can just mention we have just 10 minutes left. So I will maybe save my part of script for the next time. I will try to answer. No problem. Actually, it's even more beneficial. So actually, I can show it more. But actually, I would like to, because it was already some question here. I saw it. If it's possible to make drawings by the Grasshopper Tekla Live Link, and the answer is pretty easy right for now. That actually it's not this option is not available. We've been discussing that in during meeting in McNeil with Sebastian, but it's really actually interesting topics. And there's some two projects that are ongoing on that. First one that I would like to mention is Asha Beam. Actually, we have Asha together with us from Vietnam. So he has a YouTube channel that he actually is developing this Grasshopper Live Link. So this is also something that you can follow. And there is also another project that is ongoing on that is actually made by Grzegorz Olszewski. And Greg, you are with us.
Hi, hello everyone. Thanks for invitation, Chris and Sebastian. Just a small comment from the data developer perspective. That if I look today, what I was working, I was deconstructing the grid to get those axes by the Tekla Open API. I was also trying to get the top faces of some boundary representation object in Tekla. And when I saw that you are presenting the same examples, yeah, I'm getting a little aware of the future of my job, because the scope, the possibilities of this Tekla API, of this Grasshopper Tekla drawing, your link, it is so impressive that truly everyone should try it and unleash their superpowers.
So just Sebastian, some comments.
Yeah, I really appreciate, Greg, that you started this project with the drawing side, because that's one of the questions we had from the very beginning, that can we please start doing something on the drawing side? And so far I've been declining it because we don't have the bandwidth to do it right now. But your initiative is really great because that gives now everybody that wants it a possibility to actually chip in, because we know some of the bigger clients, they have their own software developers that hopefully will now be able to chip in and make something great for the community.
Exactly. And I think that this is the main point, that this is the open source project where everyone can contribute, everyone can use it however you would like. So if you have any ideas, any .NET developing skills, then please just join into this GitHub project to enrich the possibilities of the drawing link, because there is a lot things to do. Now I am focusing on the dimensioning because it is the user most wanted feature. So I hope that it will be this argument to check it out, because the dimensioning is the most time-consuming thing on the drawing. So if we together somehow meet this expectation, then I really think that the Grasshopper link, both for the model part and the drawing part, will be something very well seen in the community.
Yeah, definitely. Just to briefly introduce, so Greg started some months ago this initiative on LinkedIn. You can see back him this dashboard with some plans of the videos. So actually he started, and actually link is already available to download from the GitHub. If you have the link, so maybe you can just copy this link, Greg, to the comments. So
Okay.
actually everyone can download it and test it for free. But it's just a small piece of things that you can actually achieve. And if maybe your company is looking for this plugin for drawings, so maybe you can contribute, some developers can help, maybe you can have some ideas what can be great, some workflows that your company is needing. So please contact us, please contact Greg directly. So maybe we can as a community create something together.
Exactly, because I really like this approach both from you, Sebastian, and also from the Rhino guys, that we have to be user-centric. So you have to express your feelings and we will try to address it. So that's all.
Yeah, and Victor says that making up 2D drawings was always a terrible routine work. Okay, so I think there's lots of people that will be interested, so hope to reach you. So just write in the comments that the link, how can they reach you? Is there any way so that people can reach you out?
Yeah, I'm trying to copy paste the link to the YouTube channel, where there is the quite short video about the installation of the link and how to start work. So I will do it just right now.
Yeah, so any feedback will be appreciated. So if there's more people who join, so this project has a possibility and maybe will be success to develop. So great for presentation. So we have still some comments. You can stay with us. Let me see. I will just show some comments. Let me see. Victor is asking you, Sebastian. Let me see if you have any testers. Let me see. I think near this question somewhere, that if when you are releasing some new feature, if you actually do you have any testers? Because we have a volunteer that can test all the all the new stuff that actually you are doing.
Yeah, that would be very welcome. I mean, I don't know if you have my details somewhere. Did you put it up on the slide in the beginning? But it's basically sebastian.lindholm@trimble.com. So if you send me an email, then I'm happy to get in touch with you, and you can get a preview of what's upcoming.
Yes, let me see. There we have some question. Elizabeth, I haven't forget about you. Good to see you here. Can you also switch in Grasshopper between component and part in Tekla during a script in Grasshopper? Between component and part. So actually, it's not the question about changing component into part.
Yeah, it's this component word which is ambiguous because it means so many different things. I'm not quite clear here.
Yeah, if you can, Elizabeth, just yeah, if you can just specify a little bit. Let me see. We have Rolando. Are there any reference or examples that you can share about concrete rebar and rebar groups components?
Yeah, you should go to the link download page on Tekla Warehouse. There's an example called, I think, reinforcement example definitions, which will generate some different parts with rebar groups in them.
Yeah, this is really a good example for all the rebars. You have tapered, you have curved reinforcement, and double curved reinforcement. So yeah, this is lots of good examples. How about point clouds?
Not sure how you deal with them in Rhino Grasshopper, and to be fair, I haven't even tried that in Tekla, even though I know it's possible. But we're not interacting with that through the link anyhow, at least.
No, but actually you can, there is options for some types of meshes, of point clouds, to import directly through Rhino. But if you have more advanced meshes, so you can actually have some plugins. Visos, I think it's called the one who's really most famous about the point clouds. Actually, you can import it. So, for example, if you would like to have some clash detection or just see what's existing, Contra does in Tekla. So actually, you can check it in Rhino. You can just skip the part Tekla, but also, of course, you can also visualize that in Tekla. Let me see. Let me see. Here is a question of Tama. Could you please let us know how does develop a Grasshopper Tekla structural designer looks like? That would be awesome to add function from the live link to Grasshopper Tekla structure design one. Maybe any webinar about it. What do you think, Sebastian?
Yeah, we do have the TSD link, which we showed a bit of in the last webinar. And we were planning to show a bit more in this one, but we will run out of time. So I think there's material there for an upcoming webinar.
Yeah, I'm not a Tekla structure designer user, but I'm really willing to see this link. So maybe this is a good point. So just let us thumb up if you will be interested in that one. AI, the documentary, is there a way to check the overlapping of bars between them with Grasshopper in Tekla? Yeah, actually, this is what Sebastian showed, that you can get all the shapes, and with the profile that actually your existing rebar is. So actually there is from Rhino version 7, there is a component called Clash. And actually you can check it with, in this case, it will be 2 solids or 2 meshes. So actually you can check all the clashes between reinforcement. Is there a question? Can you, Sebastian, will you share this a part of the script that you showed today that you managed to present? Is this something that you can share?
Yeah, I think I will try to add it to the frequently asked questions page, which I had previously. So just, I think they would be suitable to share there in the near future, hopefully. Yeah.
Let me see. Hi, Chris, Sebastian. Is it possible to orient parts along multiple curves at once? It's a question from David. Orient parts along multiple curves at once. Yeah, my quick answer is like with data trees, you can do everything at once. I don't know if it's referring. Maybe it's something.
Yeah, it's either that or somehow like when you sweep using 2 rails or something like that. I'm not entirely sure. But if it's just about like doing several parts at once, like Chris said, with data trees, you can do anything, but they are also tricky to master.
Yeah. And Ashabim actually wrote a comment. So if I can one day, I hope can introduce about my plugin Grasshopper Tekla drawing to everyone. So of course, this is something we'll open. So we'll see if there will be interest, but let's promote it. Let's promote it. From Claudio, any preview on Sebastian new developments? Something about the drawings. So we've been talking about the drawings lately. Any something that you can share a little bit with user Sebastian, that something you are working on right now?
Yeah, on the modeling link, I don't think there are any like great big reveals to be made at this point. Of course, the more exciting stuff happens with the drawings now and Gregor's link. And also Asha Bim's link, of course. I haven't tried it myself, but from what I've seen in the example videos, it seems really capable.
Yeah. Elizabeth, she just following question. I have a group custom component placed with Grasshopper and want to change one object part into the script. Okay, so group is some custom component placed with Grasshopper. Okay, so let's say that we have some custom components and I want to change one object part into the script. Okay, so if we can receive some information from component, and for example, let's say that we have just one beam or one column from this component, custom component.
I mean, I'm not sure if that's what we're looking for here, but you can deconstruct like a component using the deconstruct component in Grasshopper, and from there you can get the objects that it has generated, and then you can use the, for example, modify beam component to change it.
I think this is a question. I think like the construct component, so you can get actually all the even not elements. You can also get all the cuts, Boolean cuts as well. I think so. You can so you can sort it out and choose a part which you are interested, and then actually you can. Are you showing that? So maybe we can just.
I was thinking we can show. Yeah. Let me get back to that. That was a component, I think. So if I have that referenced into Tekla, well, first we mentioned the deconstruct component, and here it will show you the object it created. So we have a plate, the weld, and you can then filter them based on the name, for example, but then we have this modify component if you want to change. Let's see what happens now when I have, well, there are stuff that aren't plates there, so I would need to filter it first. But then I could basically change here the profile of the plate, for example. And I think that the get children is also a shortcut to that one, so it should contain the same objects in the output. And okay, and also some kind of phantom points which you can filter out.
Yeah, I think that's it. Yeah, you can find this video recording. You will get on the YouTube. You will find it, and you will get the link after this video, and it will be available. So that's a point. Here we have some question from Victor. Personal, maybe a little bit. Chris, Sebastian, Gregor, Asha, and other developers. How do you see it? You are competing or fulfilling each other? I don't think so. We are competing. We are just helping. In my opinion, we are helping industry to develop, and this is how Grasshopper was made. Actually, every single plugin was developed, and not every single, but most of the plugins are available for free. And actually, they are fulfilling and just creating amazing tool, which is Grasshopper. And we hope that it will be the same with Tekla Live Link. Do you have same opinion, or do you think that you're competing with Greg or
good answer.
with Asha Vim?
No, definitely not. Like I already said, they are focusing on the drawing side, which I don't have the capacity to do. So I'm really thankful for their contributions here.
Yeah. We have already Let's Construct IT. We are aiming different goals, but I hope the whole community will benefit of it. So yeah. Yeah. I think just a good comment from Greg. We missed as a construction industry the open source part of the work. So let's change it. It's a good comment actually. So let's change it. So if you can help in any way, so just do it. Okay, we are almost finished, so we will split that. So this gives possibility to make this like a second part. Let's finish here. For those who I saw some comments, someone just saw my new T-shirt. I don't know if you see it, Sebastian.
That's really cool.
So yeah, so just the words are that I just started doing my project, new training about learn Grasshopper in Tekla. So it will be more specified for users that actually went through my training fundamentals and know the basics. So it will be second part. It will be to take this to the next level. So this is something I'm going to develop for the next month. So you will for sure will hear from me more afterwards. Okay, I think, let me see. If there's some question, I forgot. So sorry for that, but if you can write it really fast so we can answer, but we are already out of time. Let me see. Here we have some question. There is a possibility to detail in Tekla, for example, any kind of abstract geometry of roof canopy made in Grasshopper. Of course you can make all the abstract shapes. Of course you have some limitation because Tekla models with the polylines and with the polygons, so you will not get all this like amazing curves, but actually you can get a really good approximation.
Yeah, and also place the connections and all that. That's something that might become really easy with Grasshopper and really reacts then to any changes you have. There was a basic example, I think, in the last webinar about placing connections on a warehouse, just if you want to see how that might work. That's the same then, even if the geometry is something more complex.
Yeah. Any news about the Grasshopper custom component 1.3 version? Do you have any news about that?
No, I have very little feedback about that one, so I think it works well enough. So I haven't been planning any big updates at this point. If I had time, I would like to work a bit on the user interface and make it more customizable, but that hasn't been now the priority.
Yeah. Okay, and that's everything for now. Thank you, Sebastian, one more time. It was a pleasure to go to, and we see that there is still a lot to cover. We thought when we were planning that we will cover all the tips and tricks, but actually it looks like there is a bunch of components that actually we can show. So yeah, that will be a new possibility to meet each other again, if you will, of course, agree on the second webinar and show something interesting, because we got really good feedback from people. I see that some amazing, Krzysztof, great to see what you told us about down in Barcelona live. I don't think so. It was Bar or it was Barcelona. Maybe it was on the after party. So lots of comments. Thank you for people, Omar, Pavel. Thank you again, Sebastian. Do you want to wrap up?
Yeah, thanks everybody for attending, and it's really good to hear your thoughts and feedback and all your questions. And nice to see that we have material for another webinar. It's quite fun to make this with you. So I hope we'll be back soon.
Yeah, and you have one things to develop about this control numbers taking automatically. So this is maybe
exactly.
you will be left with the one development. So that's okay. If we're going to every webinar some developments to Sebastian. So this is a good start. Okay, thank you very much, and hope to see you next time. Bye bye.
Take care. Bye.